Now, first question, rectangular coordinates. How are rectangles, what dimensions do you normally use with rectangles? X and Y. What else? Length and width. The rectangular coordinate system, if you have a length and a width, usually it's the same as an X and Y. Usually have an X-axis and a Y-axis, and you have an origin, just like we talked about in Chapter A. We already talked about Descartes was the one that came up with the rectangular coordinate system. Okay? So, when we start our second chapter, like I said, a lot of this should be review. So let's just get through it. That way I can say I covered it, and that way you can say you know it. The quadrants start off with 1 in the upper right, 2 upper left. They go in counterclockwise order. The main thing are the signs, and we've talked about how important the signs are in Chapter A. A lot of people miss their signs, and they didn't do well on the test. So those are, a review of the signs, how they work. A is usually the first coordinate, left and right. That's a 2.
No.
Roman numeral?
No.
Right there?
Yeah.
A smudge. I don't think it's important to the... Well, I'll get over it. 2, 3, and 4. Oh, yeah. A is the first component, horizontal. B, vertical component. You need to learn horizontal and vertical versus X and Y and A and B and things like that. The first one's usually the horizontal, and the second one's usually the vertical. Because that changes once you get to the trig. We have one that's an angle and one that's not. But anyway, you have your unit right here. On the graphing calculator, we call this a scale. That's the scale of 1. On this one, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's -5. If I were to ask you to reproduce this, and we have 1, 2, 3, 4, 5 up here, -5 down here, 5. One thing kind of useful about this slide is, if I ask for the x's, which would mean the horizontal, the textbook will give it to you in order of x minimum, x maximum, and the scale. That's -5, 5 to 1. That's what that notation means. You're going to see it a lot in this book. The graphing windows will be given to you as brackets with x minimum first, x maximum second, and the scale, or the unit of measure. In this case, every tick mark means a 1. They'll also give you the y's, or they might do a time sign. But in this case, y's are -5 to 5 with a scale of 1. That's what that means, x minimum, x maximum, or y minimum, y maximum, and y scale. You're going to see a lot of pictures, and you have to get the scale right to know what points they're talking about. So, if you want to change on your calculator, you could. Under Window. Thank you. So under Window is what you would go to see the x min, the x max, and the x scale. Don't go to X resolution or anything like that. Just go to Window. That's where you get the x min, the x max. Theirs is -5 to 5 with a scale of 1. Y minimum -5 to 5 with a scale of 1. X resolution just stays where it's at. We don't mess with that. You always need to make sure everything's cleared out of your y equals. And if you hit graph, you should get -5 to 5, scale of 1. Not too difficult. Okay? So all the quadrants are there. Because the hardest thing about using a graphing calculator is seeing the graph. That is the hardest thing about it, is looking in the right place to see the important features of a graph. All right? And they'll tell you in your book, they'll tell you in the problems, what picture they're looking at. The book's very good about that. Excuse me. This textbook also has a lot of pages in which they tell you how they're doing things with the calculator, so that's good also. All right, back to the coordinate system. I'm not going to do all these, just a couple. I don't even feel like doing this one. I will do it, what the heck. -3, 1. It just says, doesn't say what type of figure it is. Plot the points. -3, 1. Here's A. 3-1 is B. Yes, Abigail? There we go. Perfect. C is -2, -3. And D is 0, 3. 1, 2, 3. Does that look right? E, 2, -3. Holy cow. 2, -3. Whenever you have a bunch of points, you can list them using the capital letter, and then you can just fill it in. But I thought this was C is -2. Yeah, it is. I don't know if I can move it. Yeah. -2, -3. There we go. Oh, if you connect A, B, I, C. A, B, B, C. Nice. C, D, D, E, and E, A. Very nice. Whoop-de-doo. All right, so it turned out to be a star. I was expecting something else. But anyway, just a review of the points, how it works. Don't try to graph points on this calculator. It's not worth it. It will be when we start doing some regressions. But right now, it's not worth it. Just put the points on there and try to connect them. I don't know. I think you can find the coordinates pretty easy, can't you? Yep. Yeah. A would be 0, 4. The axis is the only thing that gives people a problem. So, I don't know. You can figure out the coordinates. That's all right. Distance formula. I really don't use the distance formula a whole lot. And we talked about this in Chapter A. I use the Pythagorean theorem. But some people like the tried and true distance formula. I know some of you have it on your calculator. Make sure you have the exact value given unless it asks for the midpoint. Okay? But if you're given, I always use it, if you're given 2 points, x2 and y2, x1 and y1, like I said, this distance is the difference of x2 minus x1. This difference is y2 minus y1. Well, those are legs of a right triangle. That's why I always, found the distance to be the square root of the legs, difference of the legs. So I always use the Pythagorean theorem when push comes to shove. In calc, we use this a lot, not with points, but with expressions, with trig functions actually. So it's pretty nice that way. But nothing to, just kind of like a review there, the distance formula. That's pretty good. Midpoint formula. People always forget it's the average of the two. It's the average divided by 2. If you don't need to write it down, that's fine, but you have to add them together and divide by 2 instead of subtracting, divide by 2. Yep?
What did you have in the hypotenuse for your triangle again?
In the hypotenuse, I had the distance is equal to the difference in the legs squared. Okay? I just remember the difference in the legs squared, and I do that quite a bit. So, actually, it'd be the sum of the legs squared. Thanks. It'd be the sum of the legs squared. And the leg are the difference in the x's and the y's. But I know a lot of people like formulas. They like to remember formulas, which is great. I just kind of think my way through it. Midpoint, that's easy to remember. Trying to think if there's any catches with the midpoint. I don't think there is. No, any other questions? Should be pretty. Find the distance of A to B is what this notation means. Find the distance AB between A and B and find the midpoint of the segment AB. So let's give the calculator a good old-fashioned run through and see if it works. Or you want to do it old school? We can do it on the calculator. View, show and hide this. -4, 7. I would do this first though. I'm going to move that. Wrong one. There we go. Now I do -4, 7. And 0, -8. Okay. So, I don't know, something like this. This leg I have a distance of 4, and this leg I have a distance of 15, right? So, 16 plus 2, 25 would be the distance from A to B. 241, is that right? I don't know, does that break down? You sure? 7? No? What? I don't know. Square root of 241 would be the distance from A to B. And the midpoint. That would be -4 plus 0 divided by 2. And 7 plus -8 divided by 2. That would be -2, -1/2. That'd be the midpoint. My picture is way off scale then. All the calculations are right? Like I said, this isn't earth-shattering stuff, but yeah, this section will get a little bit better. Hi. So far, so good? Oh, on the calculator, you would take second quit, clear. I would take whichever one you pick second, and I would take 0, so this is the B point, minus a -4 squared, plus -8 minus 7 squared. That gives me the 241. Then if I was going to a decimal, I would go from there, take the square root. If I was going to exact value, I'd start looking at 241 to see if there's any like big factors, things like that. 6, 4, 5, 6, 7. It's not divisible by 3 or 9. 7 or 11? No. Is it prime? Is it prime? I don't think it's prime. I don't think so. Yeah, it might be prime. I don't know. But I'd leave it as 241 and then start playing with that. See if anything come out with it. Any other questions on distance and midpoint? Fantastic. How do you show something as a triangle with the vertices A, B, and C? How do you show something? Oh, it's a right triangle. A right triangle. How do you say it is a right triangle? Anybody? Anybody? Wonder years. Never mind. Yeah. What's a common thing about a right triangle? Has what? Has a 90-degree angle. And what else about a right triangle? You just saw me do it on another problem a minute ago. Pythagorean theorem. So what you can pursue either one of these. This one you have to find the distance of 3 legs or 2 legs, and the hypotenuse showed that it satisfied the Pythagorean theorem. How do you show 2 segments make a right angle? Oh. It's right there. How do you show something makes a right angle? Perpendicular. How do you show something's perpendicular? In vector calculus, we use orthogonal vectors. These two slopes would have to be opposite reciprocals, which means if you multiply them together, they would have to equal -1. So you got two routes that you can take. You can find the slope of AC and the slope of BC, or you can find the distance of AC, CB, and AB. Very good, nicely done. So which one do you want to do? Slope? Are you sure? Easier? We're not in this for easy. We're in this to learn. Oh, yeah. We're here to learn, aren't we? Okay, which one are we going to do? I'll tell you what. This half of the room, do the distance. If you're closest to the stereo in the first 3 rows, you do the distance. If you're closest to the microwave in the first 3 rows, you do the slope. Okay? Get started. Off you go. You don't know how to find the distance between 2 points? Where are the points? Let's see. The points are, let's see, 1, -1, and 1, 2, 3, 4, 5. This one is 1, 2, 3, 4, 5, 6, -6, 3. And this one is 1, 2, 3, yeah, -3, 1, 2, 3, 4, 5. There we go. Yeah, +3, right. So we got half you doing the slopes, half you doing the distance between the legs. I don't think one's any shorter than the other one because a lot of people have to remember the slope. Rise over run. Yes, it is. That is slope. Rise over run. How do people with the slope do? Terrible?
Whoa. Again.
Excellent. So my calculations were just like yours. The product of the slopes is -1. That shows 2 lines perpendicular that form a right angle. One of the definitions of a right triangle. The distances. What do you do with the distances? Those people over here that did it. Which one's a hypotenuse? AB is a hypotenuse. So the square root of 145 squared equal the square root of 29 squared plus the square root of 116 squared. I'm saying yay. It does, right? 145 equals 145. This is an example of mathematics, not arithmetic. People get the two confused. You're asked to define something as a right triangle. There's a couple ways of doing it. You invoke either a principle of slope or a principle of distance formula, and you follow the definition. That's mathematics. Questions on either one? That was stunning. I like that one. Did you like it? I liked it a lot. Anyway, yeah, that's a good problem. Nice way to start the week thinking. Ready to move on? Okay, waiting. Which one are you, slope or distance?
So would that just be your answer to prove that it's a right triangle?
It is. Well, all the work.
Yeah, all the way.
Yeah, all the work would be it. Satisfy the Pythagorean theorem. That's what you needed to do. I'm ready to hit the button. Ready to hit the button? Let's hit the button. Given, how do you figure out if a point, I gave this as a test question 3 times in a row. This exact problem. How many people get it right? Like less than 25%. I don't understand. It's so easy. You read it for a minute and you come up with something. I want to see if it's me or the question. Maybe I've been doing it wrong all these years. Could be. Not like I have the answers or anything. Given A is 5, -8, and B is -6, 2, find the point on the segment AB that is 3/4 of the way from A to B. Some people are finishing it up, excellent. And some people never started. That's the way it goes. What are you going to do? Did you get an answer? I don't know. What'd you get? Oh, -2/9. What'd you get? I'll come back to you. What'd you get? What'd you get in the back? Three people, 3 different answers. I love it. You over there. What'd you get? Which was?
Oh, wait, I forgot.
-3 1/4 and what? -1/2. What'd you get? Oh, you gotta get something. How do you find something 3/4? Which one's your answer? All right, so you want to go to this one. 2 people vote for that one. How do you find something 3/4? Well, you gotta find halfway first. So halfway of A and B is -6 plus 5 divided by 2, and -8 plus 2 divided by 2. So the midpoint Isn't that negative 1/2 and negative 3? Negative 6 divided by 2, negative 3, right? Oh, that puts you right here. Now you got to find the midpoint again. The question is, are you going to use B as your other point or A as your other point? It says 3/4 of the way from A to B. So you wind up right here, don't you? 3/4 from A. So I'll use this point and I'll use B again, which is negative 6, 2. And I'll find the midpoint of that segment. We'll add them together, you get negative 6.5 and negative 1. Then you divide by 2. Let's see, negative 12, negative 13 halves, and negative 1. Now if I divide that by 2, I should end up with negative 13/4 and negative 1/2. Is negative 13/4 the same as negative 3 1/4? Yeah. Nice job. Kudos. Does the logic sound okay? Fantastic. 3/4 of the way. I like those little logic problems. That's how you can make the midpoint and the distance formula have a little bit of teeth when you ask a question. Ask questions like that instead of just what's the midpoint formula. I like that. How are you doing on time? Good. I'm feeling stressed, like I'm not going to get through it all. Anything else? All right, let's try something else. Prove that C is on the perpendicular bisector of segment AB. What the heck does that even mean? I know. Well, I don't know. Here's AB. Let's just say AB is right here. AB. The perpendicular bisector means what? Yeah? Also at a right angle. Does C have to be at that point? No. C is the wild card. It can be anywhere on that segment. It doesn't have to be at the midpoint. It can be anywhere. How the heck do you know if it's anywhere? Oh. This goes back to the father of geometry. Did he talk about a perpendicular bisector and the endpoints of a segment? What did he say? Oh! You remember? You can't forget stuff you've been taught. No! Somebody has to remember the famous words that were spoken about a perpendicular bisector and a point on it. Nobody. Wait for it and think about it. What were you taught to do in geometry if you didn't know what to do? Get up and go to your desk, or get up and go to his desk and ask him? You could, but didn't you ever teach you how to draw the magic line? The magic line. The magic line that makes a problem, you draw it, and all of a sudden it becomes very clear. It's a line that's always there, but rarely ever used. What triangle has the median also as a vertex? What triangle would that be? Oh, no. It's what? Isosceles, which means those distances must be the same. Well, I think we got some things to do now. That way, it has to be on the perpendicular bisector. So the midpoint and the segment containing C must form a right angle. What's the midpoint of AB? If this is negative 3, 2, this is 5, negative 4, what's the midpoint? Negative 1, negative 1? Right? That's the midpoint? Okay. What's the length from A to the midpoint? No, you have to find out this length and see if it's the same as that length. Then that would be in the midpoint. You can't just take AB and cut it in half. You have to find the length of this segment. Well, that's the difference in x squared, which is 2, which is 4. The difference in y, which is 3, which is 9, right? So that's the square root of 13. Yeah? Oh, 1 negative 1. Thanks. So that would be 1 minus negative 4, 16. Oh, that's nice. The square root of 16 and 9. Square root of 25. So the length of that segment is 5. What's the length of this segment? Is it really? Nice. Square root of 5 minus 1 is 4, 16. Hey, it works. That is the midpoint. So far, so good, right? Now we got to find the slope, don't we? Or is there something else, some other way you want to do it? Oh, if we could do the distance from A to C and the distance from B to C, that should be the same, shouldn't it? Yeah, we can do that. So what's the distance from A to C? The distance would be the square root of 7 minus negative 3 squared plus 7 minus 2 squared. 10, 100, 25. Square root of 125. And from B to C, get a square root of 7 minus 5 squared plus 7 minus negative 4 squared. It's 2, it's 4 plus, what's 11 squared? 121. Hey, it works. So yeah, it is on the perpendicular bisector. Isn't that amazing? Well, yeah, you got to remember all that stuff from geometry. Everybody in the room has geometry credit, right? I like that. Wasn't that a fun problem? Oh, it was too. We won't do that one. Oh, we'll do 28. Find all the points in the x-axis that are distance 5 from the point negative 2, 4. Find all the points on the x-axis that are distance 5 from negative 2, 4. You got the answer already? Oh, Sam does. What'd you get? No. X-axis. What's true of any point on the x-axis? Do you know? They all have the same y. What is that y coordinate on the x-axis? 0. So while your answers were valid, they didn't quite match all the criteria of the question. Find all the points in the... Oh! Negative 2, 4. Mr. Duvall, I'm sure, did this. If you had Mr. Duvall as a teacher. A radius of 5. There. So how many answers should there be? 2. All you're doing is looking for these points, aren't you? Does anybody have an equation to solve for this? I could use this point. Does anybody know a way of putting this together for one equation or one thought? Sam? Okay. Yeah. Just set up using the distance formula. You know the distance is 5. And how do you get rid of the radical? You can square both sides. Now you got to be careful. It always brings in the extraneous roots, the possibility of extraneous roots. So you have 25 equals 4 plus 4x plus x squared plus 16. Well, shoot, all we have to do is solve that now. Let's see, 4x, let's see, 20, bring the 25 over. Minus 5, is that right? Anybody else doing their algebra? Is that what you got? Nice. Does this factor? How sweet is that? It is. I love it when a plan comes together. So the two coordinates would be negative 5, 0, and 1, 0, because x equals 1 and negative 5. Hey, my drawing wasn't too far off. Not too bad. 1, 2, 3, 4. I was only off by a couple. Questions on that? That's a classic problem, by the way. Used in pre-calc and calc quite a bit. Okay, you'll see that question again over and over probably throughout the book. Questions? You notice how the take on the plain old distance formula and midpoint formula are getting kind of a new facial look? I think there's one more to do. Yeah, one more to do. Then we're done. Find all points with the coordinates AA that are distance 3 from negative 2, 1. So that means like negative 3, 4, or negative 2, 4 doesn't work, and negative 5, 1 doesn't work, you know, things like that. X and Y have to be the same. We'll give it a minute, see what we come up with. Anybody come up with anything yet? You guys are probably way ahead of me, but I'm just going to work kind of slow to get caught up. Did anybody else use a distance formula and set it equal to 3? Good. Yeah?
Why is it x equal to 1?
Oh. Oh, yeah. Should be just 9. Sorry? Three and 9. Thanks. So we're still on the right path? All right. Five. Is it factor again? No? Yes? Oh.
I do it minus 4. It's plus 5.
5. And I'll bring the 9 over. Yeah, this makes 5. Subtract the 9. That gives me a negative 4. Two answers, negative 2, negative 2, and 1, 1. Anybody else get that? Good. Nice. I like that. I think we're in good shape with the distance, the midpoint, the 3/4, and everything else. Those are the tough ones, the 3/4 and the distance ones. Those are tough. So we just started this chapter. Thanks, 3 minutes. And it's time to let it go already. I think that's about it.